Hey people, okay, so this is a video over section 11.9, solving radical equations. Should go pretty quick. Again, check out the guided notes up at the top of the page and make sure you're following along. Thanks. All right, here we go. Okay, this is the last section out of Algebra 1. Woohoo! Kind of. I know we got a little bit to do next week, but just so you guys know that this section 11.8, 11.9 quiz that we will have is the last assessment over anything in Algebra 1. Woo! Whee! All right, so section 11.9, solving radical equations. Now, a radical equation is just basically an equation that contains a radical. Like, it's a silly definition, but it really that's what it is. It's an equation, two sides of an equation that contains a radical sign. Okay, no matter in some way, shape, or form, it has a radical sign in it. Now, what undoes a radical sign? Like if I have x, the square root of x is equal to 4, and I wanted to get this square root over to the opposite side, I would have to square the opposite side. Like think about what would go in there to make this 4. 16, right? To take this away, I would square the opposite side, square both sides really, right? And that would cancel that and make that 16. 4 squared is 16. And would that be true? 16, does that equal 4? Yeah, that does equal 4. That does check out in the end, okay? So recall that you can use inverse operations to solve equations. For non-negative numbers, squaring and taking the root of are inverse operations. When an equation contains a variable with a square root, square both sides, and so that's really what we have. Square both sides. That's really what you're doing there. Okay. So let's go for it. Let's just get right into it. Okay. Solve the equation. Check your answer. Always important to check your answer. All right. So if I have something like this, think about it logically. What number is going to go in here? What number, if I take the square root of it, is going to get 5? Obviously, it's going to be 25. But how does that work? To get this over to the other side, I square both sides. So x is equal to 5 squared or 25. Right? Okay. Take a look here. Now, same thing here. You want to get inside the house, to get inside the radical sign, I have to break open this radical by squaring the opposite side. I've got to take 10 squared to get into that 2x, right? So that's 100. And then I divide by 2. So 50 is equal to x. Okay? Same thing. I've got to square the opposite side. Don't divide by 3 yet. I've got to square the opposite side to get it, to break in to get that 3x. So this is 1 squared, or just 1. And then so x is 1/3. 1 divided by 3, or 0.3 if you wanted to give me in decimal form. Okay. All right, let's keep going. Some square root equations do not have the square root isolated. Remember that word isolated means completely alone. To solve these equations, you may have to isolate the square root before squaring both sides. You can do this by just doing inverse operations. So, for example, is the square root completely alone? No. So what I've got to do is do these inverse operations to get that square root completely alone. So now when I square the opposite side, x is equal to 81. Let's just check and make sure. Square root of 81 minus 4, is that 5? Well, this is 9 minus 4. Is that 5? Yeah, 9 minus 4 is 5. That does check out. So x is 81. That's my answer. Okay, let's take a look here. Is the square root isolated? Yes. This plus 3 is inside. Again, I can't break into the house until it's alone, and then I square root the opposite side. So x plus 3 is equal to 7 squared, or 49, and then I subtract 3 from both sides. I get x is equal to 52. Oh, whoa. Subtract 3, not add 3. Subtract 3. Sorry, 46. 46. Right. Now, is the square root isolated? No, the square root's not alone. In this case, I have to add the 2 first because the minus 2 is on the outside of parentheses. So the square root of x is equal to 3. And then I square both sides, x is equal to 9. Check your answer here. Square root of 9 minus 2, is that 1? Yes, this does check out. Ooh, this looks big and bad, but it's not so bad. Is the square root isolated? No. See, I can't break into this 5x plus 1 until I get this 6 to go away to get 4. And now I can break in to get this 5x minus 1. I just have to square the opposite side to get at it. So I go 5x plus 1 is equal to 4 squared is 16. And now I have this simple equation, 5x plus 1 equals 16. I divide by 5 to both sides. I get x is equal to 3. This would be a good idea to check our answer here. Square root of 5 times 3 plus 1 plus 6 on the outside. Is that 10? Well, this is 15 plus 1. So it's the square root of 16 plus 6. Is that 10? Yeah, square root of 16 is 4. So 4 plus 6 is 10. That does check out. Let's keep it rolling. Same thing here. I can't break into that 3x plus 7 until I get this plus 1 out of the way. So I say 3x plus 7 is equal to 4. Now I can square the opposite side to make it 3x plus 7 is equal to 4 squared, or 16. Subtract 7 to both sides. I get 3x is 9. And I divide by 3 to get x is equal to 3. There's my answer. Let's try one more of those. Now, is the square root isolated? No, this 4 is on the outside, so I have to divide by 4 to get it over to the other side. Inverse operation of multiplication here is division. So I get the square root of x is equal to 8, and then I square both sides. I get x is equal to 64. Okay. A couple more slides here. Is the square root isolated? No. Get that 2 over to the other side by multiplying it over. So 2 times 6 is 12. I square both sides. 12 squared is 144. Now this one is a little tricky. You could either divide by 2 or multiply by 5 over to the other side. I'll multiply by 5 over to the other side. I get 2 radical x is equal to 4 times 5, or 20. I divide by 2 to both sides. I get the square root of x is 10. So I square both sides. The square of 100 is, or sorry, square root of 10 is 100. Okay, don't believe me? Check our answer. You can spot check it here. 2 times the square root of 100, is that divided by 5, is that 4? Well, this is 2 times 10 over 5. Is that 4? Is 20 divided by 5 4? Yeah, that does check out. Last page coming. Now this looks a little weird. Like this looks like this is going to be really hard. But if you've got two balanced equations where square roots on both sides, you know, think about this. My square root is isolated here. So what would I do to get to the other side? I would square both sides. Well, what happens when you have a square on top of a square root? It cancels it out. So I'm actually going to be left with just 2x minus 1 is equal to x plus 7. See, it looks harder than it actually is, these ones where we have the balanced square root on either side. You can just actually just take away the square roots. I get rid of the little guy, the x here. Oops, that's a minus x, sorry, minus. So I get x minus 1 is equal to 7. And then I add 1 to both sides. I get x is equal to 8. There's my answer. Don't believe me? Check our answer. 2 times 8 minus 1. Oops, sorry, parentheses should go there. Is equal to 8 plus 7. So I've got the square root of 15 is equal to the square root of 15. So that does check out. That's a check mark. Okay, let's do a couple more. Okay, so what am I going to do to balance this equation? I'm going to get the square root isolated on each side. If I add the 6 over to the other side, that's going to give me this. Right? Do you see that? If I add this square root of 6 on both sides, that's going to leave me with this equation. Now, if I've got a square root on both sides, I can just take that square root off. 5x minus 4 is equal to 6. I add 4 to both sides. I get 5x is equal to 10. And I divide by 5. X is 2. Last problem coming. This one's balanced. So nice. So I get 3x plus 2 is equal to x plus 6. So I subtract the x. I get 2x plus 2 is 6. Subtract the 2 now. 2x is 4. So x is 2. Okay. Let's check our answer on this one. Why not? It's the last one. So I get 3 times 2 plus 2. Is that the same as 2 plus 6? So that gives me 3 times 2 is 6, plus 2 is 8. Checks out. Good. All right. Hope everybody's having a good day. Hopefully that was a quick and easy notes day.